So next speaker is Stuart Inglis from Exaba, a New Zealand-based company which has a distinguished color here. It's always exciting to support New Zealand companies, but this has a global scope, and again, I am always grateful for the support of Multicore World. So whenever you are ready.
Thank you, Nicholas.
Pleasure.
Hello, everyone. This is our second year here, so thanks for inviting us along, and we're happy to sponsor the conference. So Exaba, from the name we want to process exabytes of data. So not particularly creative, but we're quite excited that we got the domain name for exaba.com. Down the bottom there is, it looks like Photoshop, but it's not. At Waikato University, they have I think it's a 15 or more meter, $300,000 TV screen. So we stood in front of it so you could see what we're doing. My PhD is in computer science and machine learning, and I spent my life working on large data flow projects for genomics and all sorts of things. Everyone's biggest problem is always the storage. Compute seems to work, but everyone's always complaining about storage. So from my perspective, I've spent my life working on storage-related things, and so this afternoon I'm going to be talking about Exaba and our journey, what we're trying to achieve, and specifically, because Nicholas said to treat it like an opportunity. I've talked to a whole bunch of sort of technical advisors just to talk about the journey so far and what I've learnt, and it might be interesting to some of you, or hopefully interesting to some of you. So Exaba, our aim, the company's goal is to build effectively Amazon, right? But instead of as a service that you might use it online, actually as a product. So every one of you can have your own Amazon storage, cloud, compute, everything. And you go, that's extremely ambitious, right? But it's actually been about 20 years May, when Amazon first released their S3 storage, started from where the data was and things built up around it. Compute, databases, whole bunch of sort of services. Exaba's design goals really was to develop a system which was starting off with storage, and then there's a number of design goals that sort of came into it. As a sysadmin and someone who's spent my life looking after large systems, how do we build something that meets these needs? Build something that we effectively wrote everything ourselves, which is insane, right? Right now, we've run the Linux kernel, and everything else you'll see that we've talked about, we wrote ourselves to minimize CVEs with the assumption that we're not going to be a guilty party and actually generate more problems than the average sort of tool out there. Make it bulletproof, and from an availability perspective, lots and lots of nines. From a durability, crazy as well. Starting from a secure, a secure hardened operating system like Linux. Have everything removed apart from our software. Have a distributed storage platform that scales up as well as out. It runs everywhere. It's immutable, meaning that once you can turn things on, you can turn on different kinds of compliance and governance mode, multiple tenancy, super fast, and also for it to be as much as possible Amazon compatible. And we've just got, in the small, medium enterprise space, Veeam is the #1 backup tool, and we've just got Exaba Veeam approved. So we started the company about 22 months ago, and this talk is about programming in Rust and sort of our journey so far. And so as I sort of talk to you as a group, I'd be interested for you to think, you saw that how many people I had at the very start there, how much you think we've actually spent in terms of money. But just have a sort of a ponder. 20 years ago, how long did it take Amazon to build the first S3 system, and then how much is it sort of costing today with tools such as these? And I'll tell you how much money we've actually spent at the end. It'll be interesting to see how close that you've sort of got. So Rust is a programming language, and it has a number of really interesting attributes that we believe as a team, when we asked the senior developers, when we first started the company, we're like, should we write in Rust. None of us had written a single line of Rust apart from perhaps Hello World. And the first team was just like, no, okay, let's try it. So we tried it for the first month. And the only reason we got people to try it for the first month was we told them that if people didn't like it, we could delete all the code and start again in the language of their choice. So the first month was like that. At the end of the month, we had a conversation. The jury was sort of, 50-50. So we carried on doing it for another month and then another month. And after the third month, the team said we would never go back, right? So that was sort of interesting given that it was everyone's first opportunity to sort of use it. And what we've sort of seen, sort of anecdotally, if you ask myself or Pete, some of the other senior members in the team, they feel like they're about 5 times more productive, 5 to 10 times more productive than they used to be, which is an interesting kind of measure. And I'll give you some examples. So if you Google for why why it's a good idea, you see these sort of throwaway things, memory safety, concurrency, all that kind of stuff. Other languages pause for a while and do garbage collection, figure out memory, all these different kinds of things. Rust is nice and predictable. Stack Overflow, and I think it had for about 4 or 5 years. Rust has been the #1 senior programmer's favorite. If they had to pick a language to write it in, what would they pick? Department of Defense has all these different kinds of mandates saying in the future you should program in memory safe languages such as Rust, right? So there's lots of reasons sort of why, but you go, what does it actually mean? So I thought I'd, perhaps give some anecdotes. And for people that aren't programmers, I thought I'd have a little example here, right? So everyone's intelligent in this room. So imagine this kind of piece of code. A equals hello or hi. B equals A. Print A and B. You go, hands up, who thinks that will work? Okay. The answer is Rust isn't a language where it says A equals hi or B equals A. It actually is, the equals operation is actually a movement. So it says hi is sort of in A and A is now in B and there's no longer any A, right? In all other languages that you sort of write, you go A is this, B is A, print A and B, right? But from Rust's perspective, it's like, nope, you're no longer ever allowed to use A. It's sort of gone to you. And there's a number of sort of concepts like that, lifetimes and a whole bunch of things, which means a whole massive sort of an area of debugging that we used to spend our life doing. In fact, I used to spend, I've spent 30 years as a C programmer, and I used to spend perhaps equal time in debugging code as I'd spend writing code. I don't think any of our developers actually have used a debugger in the last year. It's sort of an interesting kind of framework. So what does it actually mean? Why we built it in Rust? Memory safety without a runtime stacks. So as part of that Department of Defense thing and saying no buffer overflows, that means, when you have an array going over the past of it into memory that's not yours. Being able to have, it's pretty standard in writing software to have sort of pointers where you're not quite sure of their state, lazy pointers. You might have a function that allocates some local memory and then returns a pointer to it. These things are valid in almost every language apart from Rust. All the different kind of pointer maths and all the things we used to spend our entire lives on, pointers, heap corruption, all this entire thing I haven't thought about for 2 years, which is interesting. So when you're actually writing Rust code, especially now with the Claudes and the ChatGPTs and these kinds of things, when I first started doing it, I would compile, I'll try and compile it. And what you actually see is that you used to have problems. It used to be easy to compile, and then it would run and crash and all these kinds of things. Rust has sort of changed it around and made it almost impossible to compile, right? It's really hard. But as soon as it compiles, it works, and from then on it just works forever. So it's a crazy kind of world. So these days with the online tools like Claude, for example, you say, what on earth does this mean? That the lifetime is broken in some kind of way, and it'll help you and fix your code. And It's just been a thing of sort of beauty. In a lot of other systems where there's concurrency, you may imagine there's lots of things happening at the same time, and they may, two processes or two threads may refer to a single shared piece of data. That leads to all sorts of race conditions and deadlocks, and if this shared state is in this, then do this. Rust stops that entire thing by happening by just not allowing the entire concept to exist. So all the code that you used to have by going, here's some kind of shared lock, two different things were looking at the same pointer or the same piece of memory or the same sort of category, the entire class of writing code like that, you can't write that code. So you can't have those kinds of deadlocks. So how it sort of works in the Rust world is you have separate programs or different kinds of processes, and you send messages to each other. Instead of jointly sharing something where you might get in some kind of deadlock situation, you end up moving messages and sending things through. And there's a number of different kinds of categories of the kind of bugs that would have normally shown up in asynchronous finite state machines and things. So as part of some of the architecture of what Exaba is building and what we have built is we started by we want to build Amazon, right? So we want to build a large storage system. In Hamilton there, we've got about 50 petabytes of different kinds of storage. SATA drive, SAS drive, NVMe, we've got GPUs, we've got all sorts of things. We effectively convert all of it to look like NVMe over Fabric, so it becomes a network issue. We have the Linux kernel, and then on top of that, we've written everything ourselves, making sure that every drive is exposed the same kind of way. And we wanted to build a system that our first target market that we went for is to go crazy ambitious to build Amazon. When we talked to people about storage, the number one market that found out what we were doing, because when we started, we actually said, we're going to be building storage, and some managed service providers found out what we were doing. At the time, I have to confess, I didn't even know what a managed service provider was. But it turns out there's about 340,000 managed service providers around the world that look after most businesses. So most businesses have their own internal IT as well as a managed service provider. A managed service provider may come along and they set up your machines and they set up your computers and your networks and primarily your backup. And they back up using Veeam as a common backup tool, and they back up your data to Amazon, and they back it up to Wasabi or Backblaze or these kinds of tools. And what the managed service providers basically said was, oh, okay, so you're building this for us, right? Instead of us saying, we'll configure our customers' machines in Hamilton, Australia, wherever they are, to back up to the other side of the world or to Amazon, they're going to back up to a hyperscaler. They said, you're providing us the technology so we look like an Amazon. So instead of us picking our customers 10 petabytes of data, shipping them over the other side of the world and getting a 10% kickback, are you building something so we can look like Amazon? And we're like, yeah, but that's exactly, we didn't know we were doing that from the sort of a market perspective. But effectively, over the last year and a bit, we've sort of changed the way we're positioning and saying we're still doing exactly the same thing, but we've had interest from about 40 different managed service providers in New Zealand, Australia, and the US. Who said, if you build it like this, right, enabling us basically have a, s3.nicholas.nz, he's now Nicholas Cloud, right? So instead of being a hyperscaler, what they want to be is a local scaler. So we've sort of coined this word, and very much it's completely aligned with our favorite topic of sort of sovereignty. It's really hard to have any kind of sovereign do-it-yourself system, right? When we talk to the managed service providers, they're like, why don't you use the open source systems? They can't find the people, they haven't got the skills, all sorts of things. So what we've been building is we effectively built the system in Rust that's bulletproof, looks like Amazon, and we actually manage it for them, right? And so they're like, oh. So these managed service providers we're talking to, We've worked on these kind of things. Support any of the, we're vendor agnostic. Some of them are HPE, some of them are Dell, Supermicro. We assume everything fails, and so we're extremely resilient. You know, I've got experience with sort of huge systems. Everything can fail. The worst things are unfortunately humans. Yeah, things are being recorded, but there's a very big, well-known New Zealand company, you know, has lots of data, and their sysadmins go, I think that customer's left. Delete the customer when the customer hadn't left, and $2 million later, they still couldn't bring the data back, right? So some of the managed service providers are like, as a director of the company, you've outsourced responsibility to a salaried sysadmin, but they've got the power to wreak incredible havoc, right? So they ask us for things like, as well as the Amazon immutability and things, they say, can directors have 2-factor or 3-factor authentication before you delete buckets? And all these things that are actually sort of practical reasons of how not to bankrupt these small kind of businesses. And of course, you walk around, as I do, and just ask people where they're hosting their stuff. And they're hosting it in the Oracle cloud, we're hosting it on Amazon. And where's your backup? Oh, the backup's on the same cloud that it currently is. And you don't really say anything because the CEO's in the same room, and the CEO looks at their head of CIO, and it's sort of something that sells itself, really. I've been told many times that the CEO, and it's been quite funny as a real-time conversation, that the MSPs say this is the simplest thing in the world to sell. They're going around, and very few people are doing it very well, unfortunately. So we started with our rocky Red Hat Linux, which is written in C, but Linus has said that, you know, he started accepting Rust patches. There are rumors of a Rust mini kernel, which would be quite cool for us to run on top of that. So right now we've got the rocky Linux that we've basically taken everything that we can out of. We've just removed every package, perhaps apart from the file system, and it's just an Exaba simple OS. We've removed everything. And the defense, there's some the defense people love acronyms. The DISA STIG figure, for those who can't read it, Defense Information System Agency Security Technical Implementation Guides. The aim is to basically how secure your system is. And we get a 98% out of all these kind of tests after we remove it. And of course you go, why didn't you get 100? I've been told 2 reasons. You wouldn't believe me if I said 100, but we missed 2% because it wasn't looked after, supported by Red Hat, right? So any derivative of Red Hat was like, you're sort of a derivative and you're only a little company versus a big company. So apart from that, all the security things were there. We just didn't necessarily have the chops. We lost 2 points for not being Red Hat. So what people want, we didn't realize that the MSPs would be drawn to this, right? We originally wanted to build it for enterprises, HPC systems, the things that we've had our sort of experience in. But people wanted the hyperscaler, but local, so they called it the local scaler. They wanted to actually, sovereignty has become a word that overseas companies use, meaning to bring their stuff on our shores. But here we're actually saying to people, we're happy to show you our source. There isn't really a common word for it, but it's not open source because we don't want to give it to you for you to put it on Reddit, but we're happy to show you the source, right? So it's like, the source is open versus open source. You know, the aim is to say, you can see our software, we're sort of proud of it. You can see how your data is being stored and encrypted. A very high level of sort of trust behind these things. So a lot of people talk about sort of end-to-end encryption. And for the sort of geeks in the room, like when you see your web browser, HTTPS, it basically means it's secure from you to somewhere. It's not always all the way to the website. Sometimes it's secure to the load balancer of your service. It's actually encrypted to the load balancer, and then the load balancer figures out where the data goes. and then it's decrypted and then re-encrypted. Lots of big corporate firewalls do a similar kind of things. We've developed our system in such a way, just like Amazon, for example, if you look up s3.amazon AWS, .com on the East Coast, there's 17 to 20,000 servers, all in that same domain name. And when you connect to them, you connect directly to the nodes, which is the same way that we've done it, and making sure that our key exchange mechanisms are all the best they can be, the post-quantum algorithms, and making sure it's sort of bulletproof. Currently, we're using Linux, and currently we're doing backup. So the backup systems, Veeam, as I said, is the most common tool for small businesses. It's like 75% of the market or more. It actually, from a usability perspective, it's really easy to use, right? Back up my server, point it to, currently it's pointed to s3.amazon.com. Nicholas has got his great business, add another pull down, s3.nicholas.nz. And you go, oh, it just starts sort of backing up. Let's have another one, S3, the Glacier storage, the cheaper, more durable, much cheaper version of Amazon. And then you go, our aim is to enter the market at a 20th the price of Amazon, right? So instead of paying $40 New Zealand or $23 US a terabyte, we're saying $1, right? So it enables Nicholas to have his business on top of us, still charge his customers maybe quarter what they used to charge, and still run an 80% margin business, right? And you can only do that when your competitive factor is price. You have to be so much cheaper, right, to enable businesses on top of you. One of the amazing things is I was showing this, I think this was from Stack Overflow, is the system that is used to basically build Rust code. It's called Cargo, and it was voted the most admired tool for the year. And this is sort of a crazy, this is like, tools like Terraform, which is used for structuring things on the cloud, and Homebrew, which every basically Windows and Mac developer in the world uses and make, and it's better than any other tool by a long way. And it's amazing, right? It builds your system. It also constantly looks at all the bits of, it checks your licensing and makes sure you haven't violated some license term. It checks CVEs, it checks things out of date. It enables you to have an auditable chain of custody. It has all these kind of features built in, and it's crazy. It's almost got every feature that everyone wanted, and I didn't realize that because I was just impressed. And you never know whether everyone else is impressed by the same thing. You just go, well, this is amazing, really. So, for example, right now, the reason why you can write your code so quickly is there's becoming a public ecosystem of crates, for example, like shared libraries. But each one of them you aren't just downloading it and just running a free-for-all on it. You can see it's been audited by Google, it's been audited by IBM. Someone's gone through and read it, and then it's been approved, and you can only use code that has been audited by these people, and you can audit it yourself. And there's this crazy level of trust that you can sort of build up, and it ends up, you can ship code, and as part of being a trustworthy provider, if I send my code or it's installed on Nicholas's as my MSP here, he can actually independently verify it. He can actually run to go, this is actually not just what he thought it was, but he can go back and check it against all the original sources and make sure it hasn't been perturbed or any viruses, or he can always just constantly be sure of exactly what he's got. And it's got lots of other attributes as well, but it's just part of a bulletproof, trustable system. So for those who are sort of used to large systems like Kubernetes, it goes, why didn't you just use that? And really, when I said we were building everything ourselves, I really did mean every single thing. We built 25 parts we built the web server, the DNS, the drive layout, the communications, the security side of it, the key management, the alerting, every single part. So we didn't have to rely on other parties. Normally when you have, in an operating system world, you want to use one package, so you install that package and it brings in like 50 other things that you didn't want, right? We want to exactly know what we had, and you go, well, it will be faster. Everyone said don't do that because it'll be faster, but this sort of estimate for what I will sort of show you how much money we spent, you go, yeah, it'll be interesting to see. We basically own the entire thing, every single app, to enable us to completely understand every line of code. A number of people that I know, and I was hoping to talk to our friends from Catalyst, but he couldn't make it. But there's people build open source systems, and they're probably more flexible, less opinionated, so they can do more stuff. But they're huge, and if you have to add features to them, it's actually harder. When things are smaller, they're easier to sort of change. So we'd like to run Exaba in lots of different places. I spent my life trying to port code to different platforms. Haven't got much here, as you can see. We wanted it to be fast, so that's the current speed of our current systems. 190 gigabits a node is currently our sort of systems. We're obviously here to, find people with bigger systems than we've got, and we're always interested to talk about these kinds of things. We are interested in, this just talks about the speed, and our marketing person took my slide and added a graph up to the right. Obviously, that's impressive. So, in terms of making it as resilient as possible, sort of from as available as possible, we do. I love planets, right? So most people would call that a backronym, but this is the first thing I thought of really. Reed-Solomon is the standard algorithm that's used for RAID. We do it in multiple areas all the time. So we've got this lovely Mars acronym here. All the data is laid out by us, so it works on zoned or shingled drives as well as normal drives. Everything is from the restore, the loading. We actually write everything monotonically, so things work very, very nicely. We've got Veeam approved, Veeam validated, so almost every vendor that sells object storage solutions also sells the hardware. Where there's only a couple of us, probably 2 or 3 of us, that actually just sell the software to enable you to run your favorite hardware. And there's a number of reasons why. Only 2 more slides. So we wanted it to run everywhere. So these are all the systems that I myself have run the system on. We've got large X banking power IBM systems. They have 256 cores and vast amounts of their own NVMe system. I think maybe it took 10 or 20 lines of code that needed to be changed for the power platform. Works on ARM, the $35 RISC-V systems, these different kinds of systems. The reason why I wanted to do that was we wanted our storage to run everywhere, right? Everywhere meaning Android devices, for example. We compiled a whole S3 compatible system that does immutability, all these things, and you can back up to your Android in your pocket. You go, where's your backup? Here's my backup. Your phone is the server, right? People think of their phone as the client, but actually this is the server side. I put lots of dongles onto the bottom of an Android phone and have 2 terabytes of little micro SD cards, and right? So here your S3 target, using a reverse proxy, you can just create a URL that you go there and your phone connects in, so you get past your carrier grade NAT from your ISP, and then you've got a URL on the internet, you've got Amazon in your pocket, Exaba everywhere. We've got developed systems so you can watch it, clusters on your watch, the status, you're an MSP, how many clients you've got, how much money that you're making, all these different kinds of things. It's in the App Store. So that's what we've been doing over the last 22 months.
Okay.
And we basically built that for 1.5 million US. So I'd be interested to see what people's, I'm also a partner in a VC firm. I see what people do with money and sort of capital. And I think that's an extremely, well, we certainly haven't built anything as big as that for anywhere near that level of sort of cost. So I thought I'd share my journey with everyone, and maybe there's some little nuggets in there or not. But.
Well, as a fact, I need to start a business this evening. Well, what is that, Nicholas Cloud?
Yeah. Yeah.
So questions for Stuart.